All right, welcome to this video on solving equations involving radicals. And as you can see on this handout, I've got some steps for solving radical equations, and I'm going to go through all the steps and how I like to perform those operations. And I've got about 5 examples in this sheet. But before I do that, I just wanted to cover some basics on what radical equations are and actually how we're going to approach solving these. So I'm just going to scroll over a little bit, and you can see I've just got a couple of quick examples. And radical equations are very simply any equation which involves an expression with a radical in it. And you can see the two that I have here. I've got one with a square root, square root of x plus 1 equals 20. And then I have one with a cube root of x minus 4 plus 3 equals 12. And these equations can come in a variety of different forms with a variety of different radicals. And the steps that I'm going to show you in this video, will work with a good number of these types of equations. So before I get into the steps in solving these, I just wanted to cover, the concept of inverse operations. And we're going to use inverses to solve these types of equations. So, if I use a very simple example, if we had x, and let's say we added 2 to it. Now, if I wanted to remove that 2, we would do the opposite of that. We would do the inverse operation, which would be subtraction. So we would subtract 2, and then we would wind up with what we started with, x. So addition and subtraction would be the inverse operations. And then similarly, if I had x again, and we multiplied it times 2, if I wanted to undo that multiplication, I would do the opposite operation, or the inverse operation, which would be division, and we would wind up with what we started with, okay? And those types of principles are going to apply to what we're going to do with the square roots. So for example, if I had x and I wound up squaring it, well, to undo that square, to get rid of that square, we would do the inverse, the opposite, which would be to take a square root. So the square root would undo the square. We would wind up with just x. And similarly, if we had the square root of x, if I wanted to undo the square root, what we would do is we would put the entire radical in parentheses, and we would square it, and we would wind up with just what's under the radical, x. So basically what we're going to do in this video is we're going to wind up using the inverse operation to a square root, which is in fact a square, and we're going to remove the radical. So we're going to wind up doing the inverse operation. And this will hold true if we had a cube root. So if I had a cube root of x and I wanted to remove the cube root, we would wind up cubing the expression, and we would wind up with just x. Okay? So if I had 2 and I squared it, we would wind up with 4. Well, if I wanted to wind up with what I started with, if I wanted to undo that square, all we would do is we would take the square root of 4, and we would wind up back to where we started. Okay, so we're going to use the inverse operation of a square root, which is a square, and we're going to wind up removing that square root. All right, so let's come over to the examples and the steps that I have here. And again, this, you can see up here at the title, it says square roots, but really these steps can be used for any equations involving radicals. So let's get through with the steps. So I'm going to write out the steps on how I like to approach these, and then we're going to work through these 5 examples. So the first thing you want to do is, I'm just going to write a very simple example over here just so we have some reference. If I had the square root of x plus 2 equals 10. All right, very simple example. The very first thing you're going to want to do is you're going to want to isolate your radical. Okay? And again, that's going to apply whether it's a square root or a cube root or what have you. So basically what we want to do is this square root here, we want to isolate it, and we want to move any terms that are on the outside of that square root to the right of it. Or even if I had a coefficient here, for example here, I'm just going to erase this. If I had a coefficient of 2 in front of that square root, I want to remove all terms in front of it and all terms behind it before I start working on the square root. So step 1 is going to be isolate your radical. Step 2 is, here's where we're going to remove the radical. So just, to go through these quick examples, what I would do is, I'm just going to erase that 2. What I would do here is I would subtract 2 on both sides to remove the 2, and we would have the square root of x equals 8. Now at this point is where you're going to work on the radical. So again, if you remember what we talked about just a minute ago, we're going to wind up doing the inverse operation to that radical. So what you're going to do is you're going to raise each side of the equation to the power equal to the index of the radical. Okay? So basically what that's saying is, if you are taking a square root, all you're going to do is you're going to raise both sides of the equation to the second power. Okay? If you were taking a cube root, let's say this was a cube root of x equals 2, then all you would do is you would raise both sides of the equation to the power of 3. That's all that's saying. All right? And then in the example I'm using here with the square root, if we took a square of a square root, what we would have here is x equals, because the square root is going to be undone by the square, and we would, take 8 to the second power, so my answer would be 64. Okay? So this was a very simple example. I didn't have to take that one any further. Some of the examples we're going to do in this video are going to be a little bit more involved. So the third step is you would solve for your variable, okay? In this case, the variable was x, and in this step, sometimes this can be the more involved step, because sometimes we might have to call on other things that we've learned, such as factoring, such as quadratic formula. Sometimes we have to use synthetic division to find the zeros of the function, of what's left over. So step 3 can be a little bit more involved than the other 2, depending on the type of equation that you have. Now the one that I gave you here was a very simple one. I'm basically done. There's really nothing else I have to do. We've already found what x equals in this example, so there's nothing I have to solve. But just note that step 3 can be, depending on the problem, can be kind of intensive to try to find those answers. And the last step, and the step that, a lot of people don't like to do, is you really need to check your answer, okay? Because what can happen in these types of equations, since we're squaring both sides of the equation, what can happen is you're going to get answers that actually don't work. You're going to get answers that don't check out, and these answers are called extraneous. So you want to check for extraneous solutions. All right. So that's kind of that's an important one that a lot of people don't like to do, kind of and overlook. All right. So these are the 4 steps we're going to do, and I'm going to work through these examples using these 4 steps, or these 5 examples actually. All right. So let's do it. So first step, I'm going to write the steps as we do it. The first step, as you recall, is you want to isolate your radical. Okay? Depending on the problem, you're not always able to get the radical by itself on one side of the equal sign. But this one we can. So what I have here is my radical, square root of x plus 6. So what I need to do is isolate that radical, which means I need to move this x to the other side. Basically, you want to have if you can, you want to have the radical on one side of the equal sign, and you want to have everything else on the other side of the equal sign, okay? And that's what your goal is. And as you can see in the next example, we're not going to be able to do that entirely. But in this example we're working on here, we can. So I'm going to subtract x on both sides. All right, so we have the square root of x plus 6 equals 14 minus x. Step 1 is done, check. Step 2 is, here is where you want to remove your radical. All right, so this is where you want to work on the radical. And this is where you're going to raise each side of the equation to the power of the radical. So I have a square root in this one, so we're going to square both sides. And on the left side here, you can see this, the radical is going to disappear because we have an inverse. We're going to have x plus 6. But on the right side, we've got a binomial, and we have to square that. So this is basically going to be 14 minus x, if I do it to the side, times 14 minus x. And if we go through the whole process of multiplying everything out, what we're going to be left with on the right side is 196 minus 28x plus x squared. Okay? And again, this example is a little bit more complicated than the one I had done before. So this is what, we're left with. And the third step, if you recall from above, was to solve. Now this one we've got a little bit of work to do. So we've got to solve for x here, and you can see basically what I have is a quadratic equation. I've got an equation with a highest exponent of 2, so we're going to wind up solving this as a quadratic equation, so which means that we're going to try to solve this by factoring. Okay? And if factoring doesn't work, then we're going to wind up using the quadratic formula. So let's see. Remember, if we're solving by factoring, what we need to do is set the equation equal to 0. So what I'm going to do is I'm going to combine all my terms. I'm going to subtract x on both sides. All right, and then what I'm going to do is I'm going to subtract 6 also. I'm going to do this in one step. And on the left side, I'm going to be left with 0. And on the right side, I'm going to write my answer here in standard form. We're going to have x squared, and it's going to be minus 29x, and this is going to be plus 190. Okay? So you can see that's why I said step 3. Step 3 can be kind of involved. And now what we're going to do is just solve this, and hopefully we can factor this. And I think we can. I think this is going to factor into, I'm going to set this equal to 0. This is going to factor into x minus 19 times x minus 10. And then, we would have both of these equal to 0. So we have x minus 19 equals 0, x minus 10 equals 0. So we're going to get two answers here, x equals 19 or x equals 10. So those are my potential answers. So remember, the last step in this is you have to check for extraneous solutions. So I'm going to do that. All right, I'm going to substitute both of these answers, x 19 and 10, x equals 19, x equals 10, into the original equation. So I'm just going to clean up the original just a bit, and we'll see what we have here. So I'm going to start with 19. We're going to have the square root of 19 plus 6 plus 19 equals 14. And if we simplify this equation here, we're going to wind up getting the square root of 25 plus 19 equals 14. And then the square root of 25 is 5 plus 19 equals 14. And we're going to get 24 equals 14, which we know is not true. Okay? So this one is an extraneous solution. So I'm going to cross this one off. 19 doesn't work. Let's try 10 and see if that one works. So we're going to do the same thing here. We're going to do the square root of 10 plus 6 plus 10 equals 14. So the square root of 10 plus 6 is going to give us the square root of 16 plus 10 equals 14. Square root of 16 is 4 plus 10 equals 14, and I think we have an answer here. Okay, so this one's good. So 10 is actually the correct answer, right? And those are the steps, those 4 steps. Again, the check is really important with these types of equations. When you square both sides of an equation, you could have that situation where you have the extraneous answer. All right, let's go to B. All right, let's go to the next step here. First one is going to be isolate your radical. And you see in this equation, I've got two radicals and I've got a constant term. So it's really going to be, it's not going to be possible for me to isolate the radicals completely. And what you should do here is when you have two radicals with another term, it's best to move the radical, one of the radicals to the other side of the equal sign. You should really split the radicals. It just makes things a little bit easier. So I'm going to add square root of x to both sides. All right. So what I have here is square root of x minus 8 equals square root of x minus 2. And then now what we're going to do is, again, we're going to remove the radical, and we're going to square both sides. So if I square both sides here, we're going to wind up with, make sure you square the entire right side. So when I square the left side, we're going to wind up with just x minus 8. And when I square the right side, again, what I'm going to have here is basically I have the square root of x minus 2 times the square root of x minus 2. So again, we have to multiply all those terms out. And what we have, if we multiply all that out on the right side of the equal sign, we're going to wind up with x minus 4 times the square root of x plus 4. If you multiplied all that out. All right. And now step 3 is we're going to solve this. So if I look at this equation, this isn't too bad because I don't have a square here. Right now, it doesn't look like we're going to have to do any quadratic solving. We're just going to combine our terms. So what I'm going to do is I'm going to combine my x's. And I still want to isolate the radical because I still see the radical there, right? You want to isolate your radical until you you don't have any other terms left next to it. And I still have this x and I still have this 4. So basically I want to bring those to the left side of the equal sign, right? Remember, we still want to isolate the radical until it's gone. So I'm going to subtract x from both sides, and I'm going to subtract 4 on both sides. All right, because we still have to, even though we removed this, the radical on the left side, we still had this radical left on the right side. So basically we're at step 1 again. So this is going to leave me negative 12 after we combine terms equals, these x's will cancel, and then, the 4's will cancel. We'll have negative 4 times the square root of x. Okay? Now at this point, you could divide by negative 4. Or you could just square both sides. It's not really going to matter. I think what I will do is I will divide by negative 4. And we'll go through the full step. We'll divide by negative 4. Sometimes when you do the division, you wind up with a fraction over here, depending on what term you have here. And like I said, in the long run, it's not going to matter. When we cancel this, I'm just going to move this up just a little bit. So I'm going to cancel these out, and we're going to be left with 3 equals the square root of x. Okay? So I still have this radical, and then again, what I need to do is I need to remove the radical. So it's isolated. We've gone through, basically I had to do step 1 twice in this example. What I need to do is remove the radical, so we're going to square both sides again. And what I'm left with, now we're at this solve step, is 9 equals x. So, that's potentially my answer. We're just going to go and check it. Last step on this one would be to check. So let's see what happens with the check. We have the square root of 9 minus 8 equals, not equals, it's minus. The square root of 9 equals negative 2. So when I take this here, the square root of 9 minus 8 is going to give us the square root of 1 minus 3 equals negative 2, and the square root of 1 is 1. Minus 3 equals negative 2, so this does check out. So x equals 9 is my answer. Okay, let's move to the next one. Now this one is going to be, even though it looks a little bit, at first glance it may look difficult, but this one's actually, compared to the other two that I just did, this one's actually very, a lot easier. It's very easy compared to those two. So step 1, again, you want to isolate your radicals. And I think we've done that, right? If you want to have the radicals on separate sides, and we've accomplished that, right? It's already set up. Then number 2, again, is I want to square both sides. I want to remove the radicals. So we're going to square both sides of the equal sign. And I'm just going to do it like this. I'm going to square both sides. And when I do that, these radicals are going to disappear, and I'm left with just 3x minus 17 equals x plus 21. And I have no more radicals left, which is good. So now we can just go through and solve this. And this one is a fairly easy equation to solve. I just have x to the first degree on both sides. So I'm going to combine my variables. We're going to subtract x on both sides. I'm going to have 2x minus 17 equals 21. And then we're going to solve for x. We're going to add 17. So 2x equals 38. And then we're going to divide by 2. And we're going to get x equals 19. Okay? Now we're just going to go through and just check it, just to be sure here. So what I have is the square root of 3 times 19 minus 17 equals the square root of 19 plus 21. Now if we simplify this, 3 times 19 is going to be 57 minus 17 equals, and then 19 plus 21 is 40. Well, 57 minus 17 is 40. So basically I have the square root of 40 equals the square root of 40. That checks, so that that means my answer checks and we're good. Okay? And those are basically the steps. So, at this point, if you wanted to pause the video, I'm going to do a couple of more. If you wanted to pause the video and try this one, I'm going to flash these steps on the screen just one more time. You can pause the video and try this one. And then I'll have worked the answer out, and I'm going to do one more, which will be a cube root, and then we'll be, I'll be ending the video. All right, so if you want to pause it and then come back. All right, so if you've paused the video and come back and you've tried it, so I want to work through the answers. Again, you have the steps on the screen. I'm just going to write it out again. You want to isolate. And it's already isolated. And then at this point, you want to square both sides. So we're going to square this side, and we're going to square the left side. So this is on the right side is very easy, right? We're just going to be left with x squared. And on the left side, we're going to be left with 6 minus x. And again, now we want to do the solve step. So I see a quadratic term and a quadratic equation. So again, I'm thinking that we can try to solve this by factoring, right? And we have to set this equal to 0. So what I'm going to do is I'm just going to move these two terms on the left side, over to the right side. So I'm going to subtract 6, and we're going to add x to both sides. So we're left with 0 equals x squared plus x minus 6. And then if we're going to factor this, let's see, this should factor into x plus 3 times x minus 2 equals 0. We split our factors up. We set them both equal to 0. So we have this. And then we're going to have an answer, x equals negative 3 or x equals 2. And then again, we're going to do the check. All right, so let's check the first one. So if I clean up the original equation, just to get rid of that, substitute it back in the original equation, we'll start with negative 3. So we have the square root of 6 minus a negative 3 equals negative 3. And we're going to have, you can see what's going to happen here. We're going to have the square root, and 6 minus a negative 3 is going to be 6 plus 3 equals negative 3. This is going to be the square root of 9 equals negative 3. And this is not going to work, right? And we could see that right away, because when we see the square root of something, and on the other side, we knew right away that this one wasn't going to work. So x equals negative 3 is not an answer. Now let's just double check and make sure everything was good for x equals 2. So if we have the square root of 6 minus 2 equals 2, And 6 minus 2 is 4, so we have the square root of 4 equals 2, and 2 equals 2, so that does check out. So this one is good. All right, that one wasn't too bad. And we've got one more here, one more example. We're going to do with a cube root, basically the same principles. We still want to isolate your radical. All right, so in this one, I'm going to add 2. Add 2. I have the cube root of 3y plus 2 equals 2, and this is a cube root. And here was where we want to remove the radical. So instead of raising both sides of the equation to a power of 2, we're going to raise it to a power of 3. So here is where you want to remove your radical, right? I'm going to raise both sides of the equation to a power of 3. So we're going to cube both sides of the equation. So if we cube a cube root, the cube root's going to disappear. We're going to left with 3y plus 2 equals 8. And then we're going to solve. And this one's not too bad. So if we're going to subtract 2 here, we're going to get 3y equals 6. And then we're going to divide by 3. And we get y equals 2. And then the last step, just do a little check to make sure nothing went wrong in our process. So let's substitute the 2 in. We have the cubed root of 3 times 2 plus 2 minus 2 equals 0. I have the cubed root, well, 3 times 2 is 6 plus 2 minus 2 equals 0. And then we're going to have the cubed root of 8 minus 2 equals 0. Cube root of 8 is 2 minus 2 equals 0. We're going to wind up having 0 equals 0, and that in fact works. So that answer checks out. And those are your steps, right? Isolate, you're going to remove your radical. You're either going to square both sides or cube both sides, or if you're dealing with a fourth root, you would raise both sides to the power of 4, and so on and so forth. And then you're going to go through that third step again, which could be the more intense step in the whole process, depending on what you're doing. This example here wasn't too bad. And then you always want to do that last step and check, because you did see we did have some answers in some of these problems that were extraneous solutions. They didn't work out. And that's it. Those are your 4 steps for solving radical equations. So hopefully you enjoyed the video. Hopefully all those steps made sense. And I am looking forward to catching you in the next video. Take care.